Hello MIS 411 class, welcome to Chapter 4 Video 2. In this video we're going to be discussing integrity constraints. And what integrity constraints are, in a nutshell, are a way to ensure that the data in your database makes sense, ultimately. Make sure that the values that you put into fields are correct or within the range that you expect, and that any references you have from one table to another maintain their integrity. That is to say, any references do not get broken by subsequent actions that you might take on that table. So the second learning objective that we'll be exploring in Chapter 4 are integrity constraints. And at this point, constraint has obviously become something of a loaded word. We've used it in many contexts. We've used it in the context of metadata, in the context of completeness constraints. We've used it in the context of disjointness constraints, etc. So once again, a constraint really is just something that limits values and actions, right? And that's the integrity constraint definition, is a rule that limits acceptable values and actions. And in general, constraint really does just refer to something that limits you in some fashion. There are three types of integrity constraints that we'll be exploring: domain constraints, entity integrity, and referential integrity. And so this maybe is a little bit familiar. Domain constraints, so a domain is the set of values that may be assigned to an attribute, or as we're calling it now, a field or a column, right? And a domain constraint are rules regarding the data that may be assigned to the attribute. So the domain is the set of values, and the domain constraint are rules that define what that set of values can be. And we've actually seen this before. So the rules might have to do with the meaning, the data type, the size, length, allowable values, and range. And if hopefully take a moment and think about where we saw this previously. And you'll probably recall that we saw this in the context of metadata very early on. We were talking about a GPA field that had to be a numeric type. It couldn't be alphanumeric. It couldn't have letters in it. So it had to be a decimal. It could only go up to 4.0. So we had a check constraint on it, preventing it from being a 5.0. It couldn't go negative. In terms of length, we said that it couldn't be, it didn't need to be 4 or 5 digits long. It could only be 3 digits with 2 of them after the decimal place, etc. Right? And then the meaning of the GPA should always be a numeric value. The data type is a numeric value, but the meaning is that it should always be a GPA. It should never be, the words "good job," for instance, which is kind of a mixture of both the meaning and the data type. But that's all a domain constraint is. Something that limits the set of data values that you can put into a field or attribute. And domain constraints, like I said, are a type of metadata that we've explored previously. So entity integrity is a rule that states that no primary key attribute or component of a primary key attribute may be null. And it also requires that every relation has a primary key. However, in database design, this part of the rule is not completely true. You can try this yourself. Go into SQL Developer, create a table, and actually you've created tables before without defining a primary key. Oracle is perfectly happy to do that. Typically, most tables will benefit from having a primary key. It gives you the ability to select specific rows, but not every table. Certainly, you can define tables without primary keys, and there are a very limited set of circumstances under which a table without a primary key is totally appropriate. That being said, for the most part, all the tables that we create, maybe not for the most part, maybe in fact all the tables we create, we will ultimately assign a primary key to. So a simple example, and again I'm trying to relate this to the tool that we're using, SQL Developer. So if you were to go into Edit Table, and again you see that the primary key, the little key icon, is right beside the column ID, okay, in the student table. So we've set the ID column to be the primary key. So here are some things that don't work, right? So here we have the data in the student table. If I tried to set some null values to the ID, knowing that it's the primary key, that will fail, right? So we cannot set null values. And the other thing, and this really kind of harkens back to what we were talking about before with regards to primary keys and identifiers, is that we can also not have the same value twice, right? So the null actually is already an error. It'll prevent this from being saved. But trying to set 2 IDs to the same value, since that's the primary key, will fail. Now, if I tried to set the first name to Harvey multiple times, that would be fine, because first name is not the primary key. But the ID is, therefore this is also not acceptable. And so if we were actually to try to run this, here I'm trying to run an update statement, which changes the value in a field. So I'm saying update the student table, set the ID to null, where currently the ID is 496. What's the error I get back? I get the error cannot update to null. All right. It'd be nice if it actually gave us a little more information about trying to violate a primary key constraint, but it doesn't. Hopefully this helps you to recognize what the issue is, though. And again, if I were to try to set the last name to null, that would be fine. It would just accept it. But because the ID field specifically is a primary key, it won't allow it. Now, there are other ways that we can prevent setting columns to null, even when they're not primary keys, and we'll talk about those later. But understand mostly, and it's very crucial that you understand that you cannot set a primary key value to null. And on that topic, let's talk about null just a little bit, because null is a little bit of a confusing topic. Null, as we discussed in class, is really just an unknown value. It doesn't mean it doesn't really mean that it's 0 or that it's like a negative value. It really just means unknown. And so I think as we talked about in class, you can't do something like if you want to look for null values, you can't say something equals null, right? You actually have to say something is null. You know, that's just kind of a thing with many relational database systems, right? But so let's look at this specifically. So first of all, the null definition. It's a value that may be assigned to an attribute when no other value applies or when the applicable value is unknown. And really, this is kind of the most common occurrence, is that we have an unknown. Or I mean, they both occur, but you'll see this quite a lot. So null is not equivalent to 0. The number 0 is not the same as null. 0 is a known quantity. It's 0. Null, on the other hand, is unknown. However, in some database systems, it is equivalent to an empty string. So I know that's a little bit confusing, but an empty string is a null in some database systems. So here, down below, you can see that I try to select from student where the GPA is 0. And you see that I get Grover Freitag, Parker Sjogren, and Jess Smilder, right? However, when I say select from student where the GPA is null, so here I said where GPA equals 0, and now I'm saying where GPA is null, right? I get a completely different set of individuals, Dakota Kulada, Darren Eisenhart, and Linda Kinzer. And you can see it's not the same group, right? So students who have a 0 are not getting picked up when I look for null, and students who have a null are not getting picked up when I look for students who have a GPA equals 0. So just remember that a null is not the equivalent of a 0. And so we've already done this example on the top, but I wanted to put both examples kind of on the same slide. So down below, we're going to do a string-based example. So you see that I'm selecting from student where the last name is null, right? I'm looking for individuals whose last name is null. I get 0 rows returned, right? Now I update the student table, and I set the last name. I don't set the last name equals to null. I actually set the last name to be the empty string, just, single quote, where the ID equals 496. Okay, and that person is actually Dakota, right? And you can see that I updated one row, and so I updated that one row, setting the last name to the empty string. And now, when I look for students whose last name is null, notice that I'm not saying where the last name equals empty string, I'm saying where the last name is null, I do in fact get that person. So hopefully that demonstrates that whereas a null is not the same as a 0, okay, null is not the same as a 0, null is the same as the empty string. So somewhat confusing, you're just going to have to kind of memorize that. All right, and so the final integrity constraint we're going to discuss is the referential integrity constraint. Okay, and referential integrity constraint definition is that a rule that states that either each foreign key value must match a primary key value in another relation table, or the foreign key value must be null. So here's kind of the book representation of foreign keys, right? You can see, let's say, the order relation. And again, I'm going to use the words relation and table interchangeably. In a database context, we're going to refer to them as tables. So here's the order table, right? You can see there's an underline on order ID that makes it what? The primary key, right? We have the dashed underline on customer ID, and in the previous video we talked about that. What that makes it is the foreign key. And so that means it has to reference the primary key in another table, right? And so you can see, sure enough, it references the customer table, customer ID to customer ID. Likewise, down here we see the, let's see. We'll come back to the order line in just a minute. The somewhat confusing thing about this, I should have mentioned this as well, is that a foreign key can also be part of the primary key. So right here on order line, right, order ID and product ID combine to create the composite primary key. They're the composite primary key of order line. However, they are also individually foreign keys. Okay, and because there's I guess no good way to represent it here as both a underline as well as a dashed underline, it chooses the full underline, but you'll have to understand that this is also a foreign key. Okay, and we'll actually see some examples of when something is both a primary key, part of the primary key, as well as being a foreign key. So foreign key relationships are sometimes referred to as parent-child relationships. The parent is the relation possessing the primary key, and the child is the relation possessing the foreign key. So the child references the parent. So let's look at an example right here, customer and order, okay? So which one possesses the primary key? So customer actually has the primary key of customer ID. The child is the one possessing the foreign key that references the parent. So for the order table contains the foreign key, customer ID, which references the parent, okay? So the parent would be customer, and the child would be order. And the reason it's called parent-child, the reason it's called parent-child is because the customer can spawn many child orders, okay? But the order can only belong to one customer, okay? And that's kind of why it's called parent-child, is because whichever one can spawn many, can be the spawner of many, is the parent, and whichever one can have sort of many siblings with the same parent is the child. And hopefully that's kind of understandable. So let's look at a couple of quick examples, and again, bringing it back to the tool we're using, SQL Developer and Oracle, right? So what happens if we try to add a foreign key to a table that doesn't reference a primary key or a unique key in another table? Keeping in mind that one of the rules is that in order to define a foreign key, it must reference a primary key or a unique key. There's actually a tiny bit of wiggle room there in another table, but it has to be one of those two things. So here, I'm trying to add a constraint, a foreign key constraint, okay, in the student table, where the student has a department field. You maybe remember that. It was just SOC or CS, etc. And it's referencing the major table on name. Now there actually might be some matches there, like there might be the Department of Computer Science, and then the major table might actually have one row where the name is Computer Science. So the strings might be the same, but what's the issue? The issue is there's no matching unique or primary key for this column list. Okay, Oracle will not allow you to create a foreign key from a table referencing another table if the other table it's referencing doesn't have a primary key, if the primary key is not being referenced, right? And then another simple example, this is where we cannot set a foreign key to a value if that value doesn't exist in the reference table. Okay, so here I say, are there any rows in the major table where the ID equals 10,000? Okay, I get no rows, right? And that's the reference table, right? So if I try to update the student major to set major ID equals 10,000. Now you have to understand that in this example, student major actually has a foreign key reference to major. Okay, we get an issue, and here's the error. The Oracle error is integrity constraint violated, parent key not found. And what it's saying is you tried to put 10,000 in the student major table referencing the major table, so the student major table referencing the major table, but the major table doesn't have a primary, a 10,000 ID. It doesn't have a row with the ID equals 10,000. So we're not going to allow you to update the table in that fashion. And so that's essentially referential integrity in a nutshell. It enforces you placing values in the foreign key that must attach to one and only one row in the referenced table. So let's continue exploring referential integrity, really with a focus right now on relating it to the concepts that we've learned in previous chapters. In the conceptual diagram in EERDs, this is how we might model this relationship. You can see, maybe you even recognize that if I started with just student and major, I might have a student must be in one or more majors, and each major may have 0 or more students, and then I might have converted this to an associative entity relationship, because again, as we move into logical design, we really won't be able to get away with many-to-many relationships. So we will ultimately have to break everything down to one-to-many or one-to-one relationships. Okay, and so and we'll see that in practice, obviously. But let's say that this is our model. Okay. What you might notice immediately is, a couple things, not all related to referential integrity specifically, but I do have an identifier, a primary key for student, right? It's ID, and I do have one for major, it's ID. In student major, when we model this, right, when we modeled in the ERD, we don't have an identifier or a primary key, right? And as I mentioned earlier, really, these relationships are what are going to define the primary keys and foreign keys and fields of some of these entities, right, or some of these tables. So let's relate this to the left, to the actual table structure on the left. So for the student, we can see that we have ID, first name, last name, date of birth, and email address, just as we did with the entity, right? And the ID is a primary key. You can't see it from this view, but I'm telling you it is. And then we have the major. Let's skip over to the major. We have ID, name, and you notice I don't have college ID over here. And left, I'm not showing it on this diagram, but I would have another relationship to a college entity, right? And that would explain the college ID. But let's look specifically now at the student major table. So the attributes in student major are type, status, started, and completed, right? Type, status, started, and completed. Now what I don't show in the original EERD, and again, this is because the relationships really are creating these fields, are the student ID, and I apologize for cutting that off, it's actually student ID, and major ID, okay? Student ID is a foreign key reference to the student's ID. Major ID is a foreign key reference to the major's ID, right? In addition to being foreign key references, these together constitute a composite primary key, as we will see here. So here's the student major table in SQL Developer. Obviously, I'm looking at edit table, and you can see that I'm on the constraints navigation, and you can see that the different constraints that this table has are a primary key constraint composed of student ID and major ID. If this doesn't look familiar, refer back to the previous video. So I have a composite primary key composed of student ID and major ID, right? And I also have a foreign key pointed to major and a foreign key pointed to student. Now, if I clicked on these, you would see that the selected columns is ID, and we again, you've seen that I think in the previous video, so I'm not going to go over that again. But suffice to say, the important takeaway here is that the student major table has a primary key composed of the student ID and major ID, right? And the student ID and major ID are also foreign keys, okay, to the student table and to the major table respectively. And hopefully that's making sense to you. So what happens, given that we've just said that referential integrity requires the child to have a reference to the parent, right? And that means that the parent has to exist. As you saw earlier when I tried to set the child to a parent that didn't exist, a major ID that was out of bounds, 10,000, it failed, right? So what happens if we set it up, right, and the parent does exist, but then we try to delete from the parent? We delete the referenced item, right? So there are three options that we have in this case, and it really has to do with how we set things up. We can either prohibit deletion, that kind of makes sense. I basically say you can't delete this major until such time as all the children referencing that major have been deleted as well, right? If there's anything referencing that major, I can't delete that major, the parent table major, because doing so would break referential integrity. Another option is to delete the child records. So when I delete from the parent table, any child table records that reference that row in the parent table would also get deleted, and that's called a cascading delete. Okay. Finally, what I could do is when you delete the parent is you don't delete the children, but essentially you delete their references to the parent, right? So if there was a child that referenced a certain item in the parent, and you delete that item from the parent, then at the child level, you set that foreign key reference to null. So instead of referencing the parent, it now just has essentially an empty value. So here's just a quick example of the first, and the first was prohibit deletion until there are no references. And this is by default. What will happen is essentially it won't allow you to delete a parent record if there are any references from a child. So let's give an example of that. So back to the student major and major table. So here we have the student major table, right? And it has major ID, which we've already established is a foreign key to the major table, okay? And here's the major table, right? And so what can we see? We can see that on this line, the major ID is 24, so that's literature and writing, right? On this line, it's 58, so that's math. And of course, we can have multiple students, different students, who are in the same major, right? So student ID 224 is in math, 58, and student ID 226, a different student, is also majoring in math, 58, right? So the question is, what would happen if I said, okay, well, math is no longer a major we offer, and I want to delete it? Now the problem, of course, what we've been saying with referential integrity is that if I delete that, then this 58 has nowhere to go. It doesn't point to any record in this table, right? So if I were to remove 58, then if I tried to say, hey, what major is this student in, it would go to the major table, try to find 58, and it would fail. And so Oracle will actually prevent you from doing that. So here I'm trying to delete from the major table where the ID is 58, right? And what does it say? It gives us a very useful error message. It says integrity constraint violated. It tells you what the constraint name is, major FK, and it says it because it found a child record, right? So if I were to delete these children first or change the major ID to something other than 58, if I were to remove all references to 58, then it would allow me to do so. So that's basically how referential integrity protects the data from essentially working at first. You know, you have these references, but then you delete something from the parent and thus causing it to essentially fail.